Hi everyone. Today I want to talk to you about three-dimensional figures and their cross-sections. We've been working with two-dimensional figures, rectangles, squares, and we've worked with length and width. And now we're going to add another dimension. And when we add another dimension, that's going to create a 3D figure. We're going to look at two particular types of 3D figures, prisms and pyramids. And then what are those characteristics that make a prism and a pyramid. Let's start with prisms. A prism is a three-dimensional figure with two congruent parallel bases that are polygons. When I name a prism, I'm going to name the prism by the shape of their base. And then when I look at the other faces of the prism, those other faces are rectangles. So the two characteristics of a prism are that there are two congruent parallel bases. They're polygons, so they can be triangles, quadrilaterals, pentagons, any polygon. And then the other faces, the other sides of the prism, are rectangles. So we have three examples here. Let's take a look at the first one. It's a little hard to see on your notes, but this shape right here actually has 5 sides, so it's a pentagon. And if we could kind of see through there, parallel to that pentagon is another pentagon. And then the other 5 faces are rectangles, which will make this a pentagonal prism. 2 faces that are pentagons, and then my other faces are rectangles. The next one's a little easier to see. This one has 2 triangles that are parallel to each other, and the other faces are rectangles, so that makes that a triangular prism. Now if you take a look at the third shape, notice this third shape is just made up of rectangles. Well, that's a rectangular prism. I can choose any of the parallel sides and call them the bases, but with 6 rectangles, it's rectangular. So a rectangular prism. So again, the two characteristics, 2 congruent parallel bases, all the other faces are rectangles. Now we can draw prisms. Don't get too worried if you can't do this. Just try it. It's not a huge thing that you need to be able to do right now, but it is something that we can do. So let's say that I want to draw a triangular prism. I'm going to start with my bases, and so I need 2, and they should be congruent triangles. Now, when you draw the 2 triangles, they don't, they can be far away from each other, they can be close up, they can overlap it. I'm just going to make them not too far away, and then just try to make sure that I made these congruent. And then once I have my 2 congruent triangles, I'm going to then just connect the vertices. So I'm going to connect that one there, and then that one there, and that one there. It's a little hard to see this one side, but you kind of get the idea that I want to connect the vertices. I'm going to do another one real quick here and just show you that it really does. I'm going to sort of slant it. So again, I'm going to connect that vertice, and then that vertice. That one looks a little better. And I'm going to just do now a rectangular one. Actually, I'm going to do square. And again, you can overlap them if you want. I think this may end up turning into a cube, but now no, that's a square prism. And then I just connect the vertices. Again, don't get frustrated by this. If you can do it, fine. Obviously, I kind of messed up on my first one, but just do the best you can. The second type of three-dimensional figure we're going to talk about is a pyramid. Now, a pyramid is a three-dimensional figure, but a pyramid has one base that is a polygon, and three or more triangular faces that meet at a point. So the difference is I have one base, and then my faces are triangles. But again, I'm going to name my pyramid by the shape of the base. So as I look at these three pyramids, notice I have triangles. I have one rectangle. Those triangles meet at a point. This base is a rectangle. Makes it a rectangular pyramid. Okay, right next to it, notice that's all triangles. So I have a triangular base, and then I have three triangular faces. It's going to make it a triangular pyramid. And then my last shape there, again, that base is a rectangle. I have four triangles. They meet at a point. Because my base is a rectangle, this is a rectangular pyramid. Okay, so again, one base, all my other faces are triangles. Now again, I can draw a pyramid. I'm going to do it the same way as the prism. I'm going to start with the base, and then only this time I'm going to put a point and then connect the vertices. So let's do a rectangular pyramid. I drew my rectangular base. Now I put the point right above it, and then I just connect the point to the vertices. And I'm going to do a triangular one as well. So I'm going to draw my triangular base, put up my point, connect my vertices, and I have a triangular pyramid. So again, three-dimensional shapes, prisms, two congruent parallel bases, the other faces are rectangles, a pyramid, one base, all the other faces are triangles. Okay, if you will flip your notes over, we're going to look at cross sections. Now, a cross section is it's just a place where we kind of slice the 3D shape, and when we slice it, it's a place where a plane cuts through the figure. And kind of think of the plane as like a slice or a piece of paper that kind of slices the shape. And we're going to slice it in three ways. We're going to do it at an angle, parallel to the base, perpendicular to the base. So when I cut through this figure, the shape and size of the cross section is going to depend on where the plane slices the figure. Now, when we work with cross sections, there's something you need to remember about the 3D shape. And what you need to realize is that when I do slice a 3D figure, that slice, a slice, cannot have more sides than the number of faces of the solid. And a solid is just another name for a three-dimensional figure. So what this means is that, let's say I have a rectangular prism. Well, that rectangular prism has 6 faces. If I want to slice that rectangular prism, the largest shape, or the shape that has the most sides, that I can do is a hexagon. Hexagon has 6 sides. So I could do a triangle, a quadrilateral, pentagon, and hexagon. I can't do an octagon or a decagon. They have more than 6 sides. So it's really important to remember that any of these shapes that we slice, as long as we have the same number of sides as the faces of the solid, we're good. So let's take a look at some examples. The first two examples we're going to look at are a cone and a cylinder. Now I want you to notice that this dotted line is going to be my plane, and notice that it's parallel to the base. Anytime I slice a figure parallel to the base, that cross section, if I were to slice that and kind of look at the two-dimensional shape, that's going to be the base. So when I look at the two-dimensional shape, it's going to look like a circle because it's parallel to the base. So the same way on a cylinder, if I slice this and then look at that two-dimensional shape, it's going to be a circle because it's parallel to the base. Now look at the next two examples. Notice this time what I'm doing is my slice is perpendicular to the base. So when it's perpendicular to the base, then your two-dimensional shape is going to be the side, that side. So when I look at a cone, and just imagine I split this cone and then I sort of open it up and look at the shape, well, that shape's going to be a triangle. And again, it's perpendicular to the base. And then with a cylinder, when I do a cylinder, again, I'm going to slice it, open it up and look at it. Well, that's going to look like a rectangle. So the shape of the face, when it's perpendicular to the base, is going to be what that side would look like. Now, let's take a look at this next one. The next one is a cube, and notice that this cube is sliced at an angle. Okay, when I slice at an angle, it's going to depend. It's going to depend on how many sides or how many faces of the shape that I slice through. In this case, I'm slicing through 3. Since I'm slicing through 3, I'm going to have a triangle. Now I could also slice it to get a rectangle, a pentagon, and a hexagon, but I cannot get anything larger than a hexagon. Same way with this, looks like a rectangular prism. This is perpendicular, and so it's going to be that side, and again, that side is a rectangle. And the shape of my cross section will be a rectangle. Now, this next figure, the next figure there, this looks like it's a cube. And since it's a cube, my cross section, whether it's perpendicular to the base or whether it's parallel to the base, is going to be a square. And then with a cube, I can still slice it and get a triangle. I could also get a rectangle, a pentagon, and a hexagon. And then finally, this last shape here, it's a little hard to kind of decipher it. It kind of looks like it might be, you could either call it a square prism or a rectangular prism, but again, it's parallel to the base, which means that it's going to take the shape of the base. And I don't know, I'm going to call it a rectangle, but if it looks like a square to you, you can call it a square, that's fine. But that shape will be a rectangle. Now we're going to do a little bit more with cross sections, so if you're a little bit confused, don't worry. We have some more activities we're going to do tomorrow in class. Again, make sure that you fill in your Google form, and we'll talk about these tomorrow.